We're going to talk about the 3 different ways that we can prove triangles similar. And this is just for triangles. It's not for any shape. These must be triangles. When we did congruent triangles, there were 5 ways. With similar triangles, there are only 3. The first one is called angle-angle similarity postulate. This is the only postulate that we have. All right. And it says if we have 2 angles of one triangle are congruent to 2 angles of another, then we know the triangles are similar. All right. Mathematically, we don't need to know the third angle because it always works out, right? If this is, just to give an example, if this is 40 degrees and this is 60 degrees, all right, then over here we'd have 40 and 60. And if I added those, that's 100, subtract from 180. This third angle automatically, mathematically, will always be the same. So we only need 2 to prove that the triangles are similar and will stay the same shape. Okay, that's the first one. The second one is side-side-side similarity theorem. It says if corresponding sides of 2 triangles are proportional, then the triangles are similar. So when I look at these 2 triangles, again, how do I know how they match up if they're not, if we don't have a statement, is you do shortest over and then medium and then longest. So the 8, which is the shortest in one triangle, is going to go over the 2, which is the shortest in the other. All right. 16 would go over the 4. And then 24 would go over the 6. And what you're going to do is reduce them, and they should all reduce to the same ratio. All right? If they do, then they are similar by side-side-side similarity theorem. The third one is side-angle-side similarity theorem. So we obviously need to show 2 sides are proportional and 1 angle being congruent, and it must be the angle that's included. So if an angle of one triangle is congruent to an angle of a second triangle, right, and the lengths of the sides, including these angles, are proportional, the triangles are similar. So the way these are marked, I know I've got the angle pair, so I would just need to put the 10 over the 2, because those are the shortest of the 2 given, and then see if it is equal to the 15 over 3. And since they're both 5 over 1, they would be. We talked a little bit in our last lesson about overlapping triangles, but I want to explain to you why we would know that these are indeed similar to each other. So notice in this first one, all right, we've got a line drawn in here, and we're told that that segment that's drawn in is parallel. So if that's the case, we actually know that that angle pair are congruent because these are corresponding, right? And we know when lines are parallel, corresponding angles are congruent. So the same thing happens on this side, on the right side. So if I pulled these 2 triangles apart and looked at the smaller one and then the larger one, they would both be marked the same. And I know then these are similar by angle-angle. All right, that's the angle-angle similarity postulate. This one, I'm not told that the lines are parallel, but I'm given that these are both right triangles. All right, and so since these are corresponding, if corresponding angles are congruent, then these have to be parallel. All right, now it doesn't do me any good in this case. Well, I guess it would. I could mark those angles because these are another pair of corresponding, but they also share this tip. So that would be the second one. So I've got my little right triangle with the box and the tip, and then we had the larger one with its right angle and the same tip. So again, you can see that these would always be similar by angle-angle similarity postulate. Now this third picture, these aren't overlapping, but again, pay attention to vertical angles. So we had the one angle pair that was already marked, and then the vertical angles give us the second. So these would also be similar by angle. All right, so just some things to know. That's why we know that those are similar to each other. So here's some examples, the types of problems you're going to be doing. All right, they want us to determine if these triangles are similar, and if so, state how and write a similarity statement. All right, so we've got triangle EFG here, and then we've got triangle RST. So what are we given? Well, I see one angle pair, and then I've got two sides. All right, so I'm going to check the side. So I'm going to put 3 over the 9, because that's the shortest and the shortest. And I'm going to compare that to the 5 over 15. So 3/9 reduces to 1/3. So does 5 over 15. So I've got two sides that are proportional with the angle that's included. So this would be side angle side, similarity theorem. And now we need to match them up. So I'm going to write EFG, triangle EFG. And that would be similar to triangle. So the E goes from that angle to the shortest. So it goes with R. Obviously, F goes with T, and then G would go with the S. Number 2, look at what they gave us. All right, no angles, just sides. So we're going to check all 3 sides. So again, the shortest, which is 22 in this triangle, is going to go over the shortest, which is 16 in that triangle. The middle length, 28, is going to go with the middle length of 20. And then the 35 goes over, the 25. Now again, if I go into my graphing calculator and type in 22 divided by 16, then hit math, enter, enter, it tells me this reduces to 11/8. 28 divided by 20, and then math, enter, enter is 7/5. And 35 over 25 is also 7/5. Problem is, this first one is not equal. So these are not similar. So you will not write a similarity statement when they are not similar. You just stop there. All right. Number 3. I notice we've got 53, 42, and then there's an 85 written in there. So I'm going to use my triangle rule. I'm going to add the 53 and the 42, and that's 95. And then when I subtract that from 180, this is going to be 85 degrees. So right here, I see I've got one angle pair, and then we've got the vertical angles. So I've got 2 angle pairs that are congruent. So these are similar by angle, angle, similarity postulate. So I'm going to pick, I'm going to call this AEB, triangle AEB is similar. So A would go with D, E goes with C, and then B goes with B. That would be my similarity statement. All right, number 4. So we've got some overlapping triangles. All right, so let's see. In the smaller one, I've got 12, 15, 18, just kind of tracing. And then in the bigger one, I'm going to have to know this whole side. So I'm going to add 6 and 18, that's 24. I need to know this whole side. So I'm going to add 5 and 15, that's 20. And then we've got this whole side, which is 16. All right, so I'm going to write it down like this. So I've got 12, 15, 18. Those are my 3 sides from the smaller one. So the shorter of the 3 sides of the larger one is 16. All right, The next is the 20, and the longest is the 24. All right, so when I compare these, so 12 over 16 becomes 3/4. Divide both of these by 5. Again, I get 3/4. Divide both of these by 6. Again, we get 3/4. So they all reduce to the same ratio. So these are similar by side, side, side. Similarity theorem. And then you pick. So if I do triangle QRP, and then I will match it up and say it's similar to triangle XTP. All right, the last two. Number 5. So what I see in this picture is some parallel lines. So I know I've got some corresponding angles. So, because this would be my transversal coming down like this. These are my parallels. So I know that this angle here is going to be the same as this angle here. All right, got that one. The other set of parallels are here, boom. So the same thing. So this line would be a transversal. So this angle and this one are also corresponding. So now I can see in the smaller and larger that these are going to be similar by angle-angle similarity postulate. So triangle LKM will be similar to KJN. All right, and then our last one. Now in this one, when I look at the smaller triangle, I see two sides, and that's it, not the third. But notice this, they share this tip, right? The smaller triangle has angle D in it, and so does the larger one. So there's my angle that I need, and I can use side, angle, side to check this out. So we've got the angle. So if I take the shorter side, 24, I need this whole side here, not just the 20, I need the whole thing. That's going to be 44. And then over here on the left, I've got the 35, and that would go with this whole side, which is 65. All right, those are the two that we are comparing. So 24 divided by 44 reduces to 6 over 11. And 35 divided by 65 reduces to 7 over 13. Not the same. Not the same. So these are not similar. All right. So these are the types of problems you're going to be looking at today. Take your time and make sure that you recognize what information is given on each problem so that you're using the correct rule. Angle, angle, side, 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 or side, angle, side. All right, you're ready to practice.